For example 3, a doorway is a parabolic arch. The base of the doorway is going to be 2 meters wide. At a point 0.5 meters from one side, the doorway is 3 meters high. So we know, given the information, that we can start the door at the origin, 0, 0. We know that it's going to be 2 meters wide, which means that I'm going to have the point of 2 and 0. It's parabolic, so it's going to come up to the curve and come back down. And it has a point where it's going to be 0.5 meters from one side is going to be a height of 3. I also know that the p-value is going to be halfway between 0 and 2, or halfway between the x-intercepts. I'm going to have a p-value of 1. There's nothing in here about the maximum height, so I don't know what that q value is. And I also don't know what my a value is. So I'm going to have to use the system of equations method again. I'm going to say that I'm going to pick a point. Let's take the 0 and 0 to make one equation. 0 is equal to a bracket 0 minus p, which is 1 squared plus q. The second one, I'm going to take that point that was given. I can't use 2 points that have the same y value. I can't use the 0, 0 and the 2 and 0 because my equation is going to cancel out and it's not going to allow me to solve for what the other one is. So I need to use 2 different y values. So I'm going to state that this one is going to be 3 is equal to a bracket 0.5 minus 1 squared plus q. I'm going to simplify both the equations. So in this case, 0 is equal to 0 minus 1 is negative 1, squared is just going to be 1, or just a, plus q. In the second one, 3 is going to equal 0.5 minus 1 is going to be negative 0.5, and negative 0.5 squared is going to be 0.25 a plus q. I'm going to use my elimination strategy. I'm going to subtract the 2 equations from each other, and I'm going to get negative 3 is equal to 1 minus 0.25, 0.75 a, and the q's are going to cancel out. Negative 3 divided by 0.75 is going to give me negative 4 is equal to a. I can also use this equation, 0 is equal to a plus q, to solve for what the q is now that I know what a is. And now I'm going to state that 0 is equal to negative 4 plus q, or 4 is equal to q. My equation is going to be y is equal to negative 4 bracket x minus 1 squared plus 4. If I was to sketch the graph with the axis of symmetry at 0, then now that I know that my q value is 4, then I'm just going to move all of these points 1 unit to the left in order to make my p-value go from 1 down to 0. So I'm going to have a point of 0 and 4. I'm going to have a point of negative 1, 0, point of 1 and 0, and that point that the graph gave me is now going to become 0.5, or sorry, negative 0.5 and 3. Actually, that's going to be up a little bit higher here. And I can draw out what it's going to look like. So if x becomes 0, how does this affect the equation? P equals 0 in the equation. Which means that suddenly my equation from up top here is going to become y is equal to negative 4 x squared plus 4. For example 4, the following gives the height in meters of a batted baseball as a function of time since the ball was hit. Now we have new variables. It's saying that I wind up with the height is going to be h as a function of t. The x, or the distance, on this one now suddenly becomes t. So now I need to make sure that I'm using appropriate variables. I go ahead and I graph this out on my calculator, putting in y is equal to negative 6 bracket x minus 2.5 squared plus 38.5. And then I'm going to graph out what this looks like. So I can take my vertex that I pull straight from my problem, and I know that's going to have a vertex of 2.5 and 38.5. I can find my y-intercept by just hitting trace 0 enter or taking a look at my table. And my y-intercept in this case is actually at 1. And I can find my x-intercept by using that second trace 2 function to find the zeros, or if you're on a Casio, by doing the graph solve and then selecting roots. And that's going to occur at 5.033 and 0. And I can draw out my graph. I'm going to label it. This is my height in terms of meters. And this is my time in terms of seconds. If I'm writing the restricted domain and range, and I use the calculator to solve for what that 0 was, I'm going to say that my domain is going to be represented by t, where the starts at 0 seconds is less than or equal to t is less than or equal to the furthest point that it hits, or when it hits the ground, is at 5.033 seconds, where t is an element of all real numbers. For my range is represented in this case as height as a function of time, where 0 is less than or equal to the height as a function of time, which is less than or equal to 38.5 is the top one, where h is a function of t is an element of real numbers. What was the maximum height of the ball? 38.5 meters. How long after the ball was hit did it reach its maximum height? 2.5 seconds. How many seconds after it was hit did it hit the ground to the nearest full second? It was about 5 seconds afterwards. And if I'm finding the height of the ball 2 seconds after it was hit, I'm going to replace my t value with 2 and solve for my height. -6 bracket 2 minus 2.5 squared plus 38.5. The height at 2 seconds is going to be 37, which means that the height would be 37 meters. And that's it.